Next problem, if the product of the intercepts made by the straight line x tan alpha y plus y sin secant alpha equal to 1, alpha lies between 0 to pi by 2 and the coordinate axis is equal to sin alpha, find alpha. So product of intercepts of the line, right? So product of intercepts equal to sin alpha, that is given. Then we have to find alpha. Given equation is x tan alpha plus y secant alpha equal to 1. So you have to write it in the intercept form. So x by a, that is x intercept, plus y by b, that is y intercept, equal to 1. So keeping x on the numerator, taking tan alpha to the denominator. So we are writing its reciprocal, x by 1 by tan alpha, which is equal to, similarly the second term, y by 1 by secant alpha equal to 1. We know x by a plus y by b equal to 1. A is the x intercept, b is the y intercept. Here instead of a you are having 1 by tan alpha. Instead of b you are having 1 by secant alpha. So 1 by tan alpha is the x intercept and 1 by secant alpha is the y intercept of the given equation, right? So product of these intercepts, which is equal to sin alpha, that is given. So product means 1 by tan alpha into 1 by secant alpha equal to sin alpha. 1 by tan alpha is nothing but cot alpha, trigonometric formula. 1 by secant alpha is nothing but cos alpha. So cot alpha into cos alpha is equal to sin alpha. We know cot alpha is equal to cos by sin. So cos alpha by sin alpha is into cos alpha equal to sin alpha. Therefore cos square alpha by sin alpha, which is equal to sin alpha, that means cos square alpha by cross multiplying sin alpha into sin alpha, sin square alpha. To find alpha, right, the angle, so we need to find tan alpha best, right? That is the idea. So first, so sin square alpha by cos square alpha, from this we will get 1, right? Tan square alpha equal to 1. Therefore tan alpha is equal to plus or minus root of 1, that is equal to plus or minus 1. If tan alpha equal to 1, then alpha is equal to tan inverse 1. So tan value 1 when tan theta equal to 1 when theta is equal to pi by 4. So tan pi by 4, tan inverse of tan pi by 4, pi by 4. So alpha is equal to pi by 4 in this case. Suppose if you are taking tan alpha is equal to minus 1, alpha is equal to tan inverse of minus 1. Tan inverse of minus theta is equal to minus tan inverse of theta. So here you will get minus pi by 4. So alpha value is pi by 4 or minus pi by 4. Next problem. If the sum of the reciprocals of the intercepts made by a variable straight line and the axis of coordinate is a constant, then prove that the line always passes through a fixed point. So we write the equation. So intercept form of a straight line x by a plus y by b equal to 1. A is the x intercept, b is the y intercept. Reciprocal of x intercept. Reciprocal of a is 1 by a. Reciprocal of y intercept, that is reciprocal of b is 1 by b, right? So they have given sum of the reciprocals. So 1 by a plus 1 by b is a constant. Let it be k. But k can be written as 1 by 1 by k. It's reciprocal. So multiplying this equation by 1 by k, so 1 by k into 1 by a, so 1 by k by a, plus 1 by k into 1 by b, so 1 by k by b, which is equal to 1 by k by 1 by k, 1. So you will get 1 by k by a plus 1 by k by b, which is equal to 1. So this means 1 by k comma 1 by k. So x instead of x by a plus y by b equal to 1, right? Instead of x you are having 1 by k, instead of y you are having 1 by k. So 1 by k comma 1 by k satisfy the particular point, satisfy the line equation x by a plus y by b equal to 1. That is the meaning. If 1 by k satisfy the equation means instead of x you put 1 by k and instead of y you put 1 by k. That is what the previous line says, right? 1 x by a plus y by b equal to 1. That means this point, the line passes through, the point is on the line, right? X by a plus y by b equal to 1. That means the line passes through that point, right? X by a plus y by b equal to 1 passes through the fixed point 1 by k comma 1 by k. Next problem. Line L has intercepts A and B on the axis of coordinates. When the axes are rotated through a given angle, keeping the origin fixed, the same line L has intercepts P and Q on the transformed axis. Prove that 1 by A square plus 1 by B square is equal to 1 by P square plus 1 by Q square. Given L has intercepts A and B with the x and y axis. So x dash x axis, y dash y axis. O is the origin. This is the line, given line L, and A is its x intercept and B is its y intercept. The intercept form of the line L is x by A plus y by B equal to 1. That is equation number 1. We know that length of the perpendicular from the origin 0 0 to the line ax plus by plus c equal to 0 is given by formula mod c by root of a square plus b square. Right? Draw a perpendicular from O to the line L. Right? So we are going to draw that line. So this is the axis L. So AB, x and y intercepts, and we are going to draw a perpendicular line from the O. It meets the line L at M. Right? So 1 implies 1 by ax plus 1 by by, which is minus 1 equal to 0. Here, so this is in the form ax plus by plus c equal to 0. Right? So instead of a, you are having 1 by a. Instead of b, you are having 1 by b. Instead of c, you are having minus 1. So we are going to use the formula. So length of the perpendicular from the origin to equation 1 is, that is OM, right? That is the length of the perpendicular. So minus modulus minus c by root of a square plus b square. So modulus minus 1 by root of 1 by a square plus 1 by p square. OM is equal to 1 by root of 1 by a square plus 1 by b square. That is equation number 2. And the axes are rotated through a given angle, keeping the origin fixed. So keeping the origin fixed and just to rotate the angle, right? So we are rotating. The given line has intercepts. So intercepts also changed to P and Q instead of A and B, right? So we are rotating the original form, right, to x to new form x dash, just rotating the x axis, and automatically y axis will shifted to this way, right? Y dash. O is the origin is fixed, right? So this is the line, right? We are keeping the line same. So AB is the x and y intercepts of the original line with respect to original position. Now it is transformed to the new position. So here P and Q are the intercepts, right? X and y intercepts. So intercept form is x by P plus y by Q is equal to 1. This is the equation number 3. So 1 by px plus 1 by qy minus 1 equal to 0. So standard form we are writing in the, here a is equal to 1 by p, b is equal to 1 by q, and c is equal to minus 1. So the length of the perpendicular. So because origin is fixed and line is fixed, so the length of the perpendicular is also fixed. So there will be no change in the length of the perpendicular, right? So this one is same, OM only. We are just rotating the axis only, right? So O is fixed and line is also fixed. So just we are rotating the lines x and y axis, right? So the length of the perpendicular is same, right, with respect to that line. So the length of the perpendicular from the origin to 3 is OM only. So which is equal to minus 1. We are using this intercepts 1 by p square plus 1 by q square root of. So that is equal to 1 by root of 1 by p square, p 1 by p the whole square plus 1 by q the whole square. That is 4. So OM has 2 value from 2 and 4. So 1 by root of 1 by a square, 1 by a the whole square plus 1 by b the whole square is equal to 1 by root of 1 by p whole square plus 1 by q whole square. So cross multiplying, root of 1 by a the whole square plus 1 by b the whole square is equal to root of 1 by p the whole square plus 1 by q the whole square. Squaring both sides, 1 by a the whole square plus 1 by b the whole square equal to 1 by p the whole square plus 1 by q the whole square. So squaring individually, so 1 by a square plus 1 by b square is equal to 1 by p square plus 1 by q square, which is to be proved. Thanks.